Hello and welcome to another Ginger Mathematician video. So today we're doing iGCSE Add Maths and we're going to do all of linearizing graphs. So this is a topic where you have the natural log of y, natural log of x, or natural log of y and x, and you have to derive the equation from it. It's called a few different things. And I put in a surprise question as well to make sure you're practicing those basic skills also at Add Maths as well. Generally, this is going to be on the paper too, as it generally uses calculator skills. Doesn't necessarily have to, but often it does. Right, let's get started. So we have question 8 here. An experiment was carried out and values of y for certain values of x were recorded. And the table shows these particular values. And we want to find that the relationship between y and x is modeled by this exponential function a e to the power of kx, where a and k are constants. And the first part, which is a nice 2-mark question, is simply draw a straight line graph for natural log of y against x. And notice the axes have changed. This is a typical linearizing graph signal that this is the topic. We have natural log of y here and we have x here. So what we need to do, in this case, we just need to add one extra row. Sometimes you have to add 2, depends on the question. Is basically we're going to take all the results in y and then we're going to find the natural log of them. So I'm going to go to my calculator. Again, most calculators can do this. I've got my TI Inspire calculator out here, which is perfectly fine. And all we're going to do here is just find the natural log of all these values. So natural log of 10. Some calculators just go Control Enter to force it to do decimals. So we've got what, 2.3. So let's pop in 2.3. Again, you can skip this part of the video if you don't find it particularly interesting, but that's perfectly fine. So natural log of 13. We do need decimals to help us plot these. So we get 2.56. Again, I'm generally doing this to 2 decimal places, or so you get 2.6, do one decimal place. And we go to the next one. So natural log of 22. So natural log of 22. Great thing about these questions, they're all pretty similar. So it doesn't really change too much. We'll call this 3.1. And feel free to fast forward the video here. Natural log of 35. Helps if I press the right buttons. It's nice to do some Add Maths. I haven't done Add Maths in a long time. 3.6. We'll call that rounded. 3.6. And then the last part. I know in like IB questions, you have to kind of show that it can be modelled this way. But again, this is Add Maths. Natural log of 50. And we get our last value, is 3.9. Okay, so we pop those values and all we're going to do is plot these values and these values on here, making sure we're nice and accurate. So we've got 15 and 2.3. My eyes are probably going to go dizzy. I think we're going up in 0.1s. 1, 2, 3, 4, 5, 6. Yeah, we are. Okay, so and always something to double check. So we're going 2.3. It's important we do this accurately. You'll see why. 2.1, 2.2, 2.3. And then we've got 2.6 at 30. Okay, it's going up in, excuse me, nice numbers here. So 2.6. So make sure I'm on the right one. 2.3, 2.4, 2.5, 2.6. 3.1 for the next one. So 45. 3.1. So that's here. 3.6 for 60. 3.1 was here, 3.2, 3.3, 3.4, 4.5, 3.6, and 3.9, so 7, 8, 9. Okay, and you can see it makes roughly a straight line here. Again, what's a straight line graph? Kind of an obvious thing to be aware of, but we need to draw a straight line through them. Again, I'm going to try and do the best that I can on here. But I think we're going to go through something like this. Okay, again, I've tried to draw a straight line that goes through those points. So that gives us the 2 marks here, which is nice. One thing to be aware of is we do have a y-intercept here. So we have a y-intercept at 1.8. That's going to be useful for the next part of the question. Now, this is the usual thing that they'll ask you here. So we need to find the equation of the line in part A. Again, that's fairly straightforward to do. And then we need to find the values of A and K, which is where students generally struggle. And something to be aware of here, we need to give each value correct to one significant figure. So don't forget to do that at the end. So we have our straight line. Again, to work out the gradient, again, we just do rise over run. Then I've done my best line here to go through the middle of all the points, try and be the same above and below. We know the y-intercept, so I'm just write this down. Y-intercept is equal to 1.8. Again, it'll be roughly 1.8. Again, if it's not exactly that, that's fine. And then we just need to do the rise over run. Again, choose some nice numbers to work with here. Let's do this in a different color. So let's go between 15 and 30, just to keep our numbers easier. So this was at 2.3, wasn't it? So let's go across 2.3 until we get to 30. And we're going a little bit above. So I think that's 2.7, I would say. Going above, so 32.7. I will say this is 15 and 2.3. And again, to work out the gradient, again, we know this from standard iGCSE, which is rise over run, y2 minus y1 over x2 minus x1 minus 15. Okay, so we can work out the gradient here. So that's what, 0.4 divided by 15. So let's work that out with a calculator. They give you some leeway. They give you some room for error here. So 0.4 divided by 15. And we're getting what? 0.03 if we round this. Okay, I think I'm happy with that. So let's call that 0.03. Again, they'll probably give you 0.02. We'll have to check the mark scheme afterwards. So the gradient, normally speaking, we'll use 0.03. Now, once we've got that, we now need to work out the values of A and K. Now, notice we've used the idea of basically y equals mx plus c. We've used this idea. However, because we have this axis here of natural log of y, it's not just y. In fact, what we've worked with is the natural log of y is equal to mx plus c. Because the y-axis is not just the y-axis, it's the natural log of y. But we can still substitute the values that usually work for a straight line. So we leave the natural log of y alone. We know that the gradient is equal to 0.03, so we put that in 0.03x, and we know the y-intercept normally is 1.8. So we're doing exactly the same thing that we do for y equals mx plus c. The only difference here is we have the natural log of y equals mx plus c. However, here we need to get an equation in terms of y, which is where your knowledge of exponents and logs come in. It's important. Now we think, what's the opposite process of the natural log? Well, we need to raise both sides by e. Okay, so that's the opposite operation we're doing. This cancels, giving us y, and then we raise all of this to e. So this is where we have to be nice and careful. We're raising everything, we're not doing it separately. But remember our index rules, which is if you're adding indices, it's the same as multiplying. So we can separate this out. This is a common topic you see in differential equations, which if you do pure 3, you're going to see. So we can rewrite this as e to the power of 0.03x times e to the power of 1.8. Okay, once we've done that, then we can work out what e to the power of 1.8 is. So again, this is where the calculator comes in. So e to the power of 1.8, that gives us 6.04. Again, we're doing it to one significant figure, so we're going to put that down at 6. So y equals 6, e. And notice this is already actually one significant figure already, which is kind of convenient. So just make it nice and clear to the examiner. A is equal to 6, and what was it, k here is equal to 0.03. If you look at the mark scheme, there'll probably be some variations because, again, we did our best line, the best fit in between here. So again, it may be like 6 or 7 and then 0.03, 0.02, which if you look at the answers, again, they will give you either of those to give you all 5 marks. Now once we've got our equation, then this is a very typical 2 marker afterwards, which is you need to solve for one value, either x or y. Here we just need to solve for for x. So y is equal to 17, so we have 6e to the power of 0.03x is equal to 17. And now we just solve for x in the normal way. So again, what's the opposite? Timesing by 6, dividing by 6 on both sides. I try and avoid the calculator until right at the end. This cancels, giving us e to the power of 0.03x is equal to 17 over 6. Then we want the opposite operation of e, which is the natural log. So we're going to do the natural log on both sides. I put a box to represent the expression. So this cancels, giving us 0.03x is equal to the natural log of 17 over 6. And then we divide through by 0.03. So to work out x, again, haven't reached my calculator until this point, is the natural log of 17 over 6 divided by 0.03. And this is where we just have to be careful with our calculator and make sure we don't do anything silly. So we want a fraction, we want the natural log. That's where you need to know your calculator, and also quickly, because you don't really have much time in the exam. I say this and then I press something weird. So we've got 17 divided by 6, close brackets. Again, your calculator might be slightly different. And then we're dividing by 0.03. And that gives us 34.7. It doesn't say anything about rounding. I'm just going to round to something kind of normal. So I get x is equal to 34.7. I'll do that to 1 decimal place. It gives us all 2 marks. So you can have a look through. You can see the table of values that I generated. Again, we've got the key equation that we have to work with so we can get a and k. And then part C, any answer between 33 and 37.5 gives you the marks. What did we get? We got 34.7, which is pretty much in the middle of those 2 numbers. Super duper. Now this is the surprise question. I told you there'd be a surprise question because it might have the word line in it, but actually you don't need to use linearizing to do these. So we've got a curve, xy equals 11x plus 5, cuts the line y equals x plus 10 at 2 points. The midpoint of AB is the point C, and then show that the point C lies on this line. Okay, 7 markers, so there's quite a lot to do here. The first thing we need to do is substitute. So wherever I see a y, I can put an x plus 10 in here. So I'm going to copy that equation. Wherever I see a y, I'm going to put an x plus 10. Equals 11x plus 5, and guess what? We get a quadratic out of this. So x squared plus 10x is equal to 11x plus 5. Bring everything to one side. It's always nice, these kind of questions. By looking at this, again, I don't think this is going to be factorizable. Only 1 and 5 doesn't really work, so we have to use the quadratic formula. So x equals minus b, so 1 plus minus square root of minus 1 squared, 1 minus 4ac, 4 times 1 times minus 5, all over 2a, so all over 2. If we simplify this down, we get 1 plus minus. You need to be quick at doing this as well, add maths. 4 times minus 5 is minus 20. 2 minuses make a plus, so we get root 21 over 2. Okay, so you've got the 2 values of x here at the points a and b. So that gives us the x values here of a and b. So we can write down a and b. We have 1 plus root 21 over 2. B has 1 minus root 21 over 2, or the other way around. And then to work out the y values here, well, we just put it into the most simple equation, which is this one. So we just basically add 10 to each of these. So remember, 10 is the same as 20 over 2. So I can just add that in. So I get 21 plus root 21 over 2. And I get 21 minus root 21 over 2. So that's my x and y. And then show that the point C, we're looking for the midpoint of AB. So halfway between these points. So if we look for the midpoint, remember the formula for the midpoint is just x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if we apply it to this, if we add these together, we get 1 plus 1 is 2, 2 divided by 2, that's 1. We do the same here because the plus root 21 and minus root 21 cancels, so we get 42 over 2. If we add the y's together, and then we divide by 2. So we have 21 divided by 2, yeah, that's equal to 10.5. So we have the midpoint being as 1 and 10.5. And then we check if this is correct. So that means x plus y, so 1 plus 10.5 is equal to 11. So all is good in the world. And even though it's a 7 marker and looks kind of intimidating, in fact, it's pretty basic skills. Like we're doing a quadratic simultaneous equation. That gives us these two answers. We then work out the y values, and then we work out the midpoint using the midpoint formula. Lots of standard iGCSE stuff, not even AdMaths. And then checking it does fit x plus y equals 11. So well done if you got that. Notice I'm working much more quickly in this kind of video compared to, say, the standard maths course, and that's why you need to try and keep up with the pace of it. Yeah? If you want to make sure you can attempt all the questions without being too stressed for time. Okay, here's the mark scheme here, so you can see where you pick up each of those 7 marks. Right, on to our next question. So again, this is a very key phrase. When natural log of y, when log of y, and this is log base 10, by the way, if you haven't seen this notation before, LGY just means log base 10 of y, is plotted against x. If I see anything like this, like log is plotted against, that's the kind of phrase I'm looking for, then I know it must be this topic, this linearizing graphs. A straight line graph passing through the points 2.2, 3.6, and 3.46 is obtained. And given that y is equal to a b to the power of x, find the value of each constant a and b. Okay, so instead of actually having a graph to look at, we've just got 2 points directly that we can work with. So notice we're considering our equation LGY, so log y, base 10, equals mx plus c. So in order to work this out, we can just do a little diagram just to see what's going on. So we've got 2.2, 3.6, so something like this. And then somewhere up here, this is going to go through the y-axis somewhere. And then we have 3.4 and 6. So the first thing we do is normal coordinate geometry. The first thing that we do here is just work out the equation of this line normally. So the first thing we do is the gradient. So we do y2 minus y1, so 6 minus 3.6 divided by 3.4 minus 2.2. Again, we can just use a calculator for this. Generally, this is on a calculator paper. Again, don't want to make silly mistakes, so why not use the calculator here? So 3.6 divided by 3.4 minus 2.2. That gives us 2 exactly. Okay, that's kind of nice. So we know this equation has the form y equals normally 2x plus c. We substitute in one of these in, so let's substitute in this one. So y is 3.6, 2 times 2.2 plus c. 3.6 is equal to 4.4. That means then that c is equal to negative 0.8. Okay, so if we put this into this equation, LGY stays where it is. M was equal to 2, so we have 2x and then minus 0.8. Oh, my sketch wasn't so good, yeah? It should have been a little bit further down. Okay, that's fine. And now we actually need to generate this. Now, to avoid students getting confused, I generally just write this as log base 10. So they know exactly what base we're working with. And we're going to do a very similar process to what we did in the first question, which is we saw the natural log and then we raised everything with e. Because we have log base 10, we want to raise everything with 10. So we want to raise both sides with 10. What effect does this have? Well, this cancels, giving us y, and then we raise everything here with the power of 10. So we have 10 to x minus 0.8. And remember, we can still divide up the indices. Even got a negative, we can still think of it in the same way. So we have 10 to the power of 2x times 10 to the power of minus 0.8. So we can rearrange this. We can work out what 10 to the power of minus 0.8 is. Let's pop it in. So 10, and then we want the raise button. There we are. minus 0.8. It's called calculator. This it's probably a little bit overkill for what we need. There's no mention of what rounding, so I'll do it to 3 significant figures. So I'll do 0.158. So this becomes then 0.158 10 to the power of 2x. Okay, so we've got that there. And again, we can tidy this up slightly. Notice like 10 squared, so we can isolate this. Gives us 0.158, 100 to the power of x. Notice it wants the b alone, doesn't want the 2 up here. So that means then that a then is equal to 0.158 and b is equal to 100. So you can see our answer here, 100 and 0.158 for our equation. And once we've got this, then this is a very typical follow-up question. We saw this in the previous one. So working out x or y. This time we're told what y is. So we have then 900 is equal to what we just worked out. So 0.158 times 100 to the power of x. And now we just rearrange this to make x the subject. So we're going to divide through by 0.158. So 100 power of x is equal to 900 over 0.158, and then we do the opposite of raising with 100, so that's going to be log base 100 on both sides. So log base 100. This cancels, giving us x, so we're going to do log base 100 of 900 over 0.158. Again, not reaching to the calculator until we've actually got to the answer we're looking for. So we're going to be using the log button, we want a base 100, then we want a fraction in here, again just being careful, very paper 2, like 0.158, press the big button and then we get 1.877, which is 1.88 to 3 significant figures. As long as you do a sensible rounding, like 1 decimal place, 3 significant figures, 2 decimal places, then you'll get all the 2 marks. All right, so you can have a look through. They've done it slightly differently. So they've used simultaneous equations with logs, which is also perfectly fine as a method. And we get 1.88 at the end to give us all the marks for this question. If you're liking this video and you want more AdMaths content, because I haven't done much AdMaths content, then please do like and subscribe and let me know in the comments which all of video will be the most important for you. I've now done linearizing graphs and I'm also done trigonometry as well. But again, I'm happy to do any other topic. Okay, and on to question 8 here. So the population in millions, so P is in millions, of the country is given by this formula P equals A times B to the power of T, so an exponential function, where T is number of years after January 2000, and A and B are constants. And in January 2010, so when T is equal to 10, the population was 40 million. Remember, population in millions, so P here is simply equal to 40, and increased to 45, so P is 45 by January 2013, so that's when T is equal to 13, so after 2000. And from this information, we need to work out B is equal to 1.04 and then work out A. So we've got 2 formulae we can work with here. So we have 45, so P is 45 when T is 13, so A times B to the power of 13. And then we have 40, that's equal to A times B. Notice we don't know A and B, but we do know T and P. So B to the power of 10. And this is actually just a simultaneous equation. I like writing it in this form because we can simply divide one equation by the other. You're used to this technique when you do addition, subtraction with simultaneous equations, but you can use division as well. What happens here is if we divide the right-hand side, A divided by A is equal to 1, B to the power of 13 divided by B to the power of 10 is just B to the power of 3. Of course, 45 divided by 40 on the left-hand side. And magically, we now get an equation just in terms of b, which we can solve. Remember, the opposite of cubing is cube rooting on both sides. So then we get b on its own is equal to the cube root of 45 over 40, which we use our trusty calculator here. So let's get over to our calculator. We have the cube root, so using this button here, of this fraction, so 45 divided by 40, and boom, we do get 1.04 to 2 decimal places. In fact, get 1.04004 to be exact. But yeah, b is equal to 1.04 to 2 decimal places. And now we can just substitute into either equation. I'm going to choose this one here. Doesn't make any difference. So that means we have a times 1.04 to the power of 10 is equal to 40. Again, we just solve this normally. The opposite of multiplying is dividing. So we're going to divide by 1.04 to the power of 10 on both sides. Usual stuff. And then we get a is equal to 40 over 1.04 to the power of 10. So we go back to that trusty calculator of ours. I love using the answer button. Nothing better. So we get 40 divided by our answer to the power of 10. And we get, again, we want the nearest integer, so it's just 27. I always write down something just to show the examiner that I have calculated it. I haven't just tried to guess it is 27, but it is 27. And that gives us a pretty fair 4 marks. It wasn't a particularly tricky part of the AdMaths test, but again, we want to be getting all 4 marks. Once we have this, then we're just going to be using that equation. So find the population in January 2020, giving your answer to the nearest million. Okay, so we've got our formula. Let's just write it down now. So P is equal to 27 times, was it 1.04 to the power of T. This is 2020 after 2000, so when T is 20, we put it in 27 times 1.04 to the power of 20. So let's go to our calculator. 27 times 1.04 to the power of 20, and that gives us 59.16, nearest million. Yep, so dot dot dot. So we just need to round it to our nearest whole number here, so just 59. And then in January of which year will the population be over 100 million for the first time? Again, typical kind of question using the equation that we have. So we want it to be over 100 million. So generally what I do here is just form an equation. So I have 27 times 1.04. We don't know the time, but we do know we want to get to 100 million or over 100 million. And now we just solve this equation. So again, the opposite of timesing 27 is dividing by 27 on both sides. This cancels, giving us 1.04 to the power of t is equal to 100 over 27. Now this all depends on how good your calculator is here. You can just solve this directly. So what I mean by directly is you can just say t is equal to log 1.04 being our base, and then the fraction, and then just solve this way if your calculator can do decimal bases. If not, you can always solve this in kind of the more classic way, which is we just use base 10 and we say log 100 over 27 for LG divided by log 1.04. It's actually just a change base rule actually that we're using, so you can use either of these expressions depending on what you've learnt in your class. I'm going to use the first one because my calculator is clever enough to be used decimal bases. So we're going to use log 1.04, and we've got our fraction 127. Press the button, we get 33.38. Now again, we just need to work out the year here. That's important. In January of which year? Well, usually we round down. This is what we do. So go t is 33, but we want to work out when it goes over 100 million. So we're actually going to have to round upwards here. So we want t to be 34 when over, or when greater than 100 million. So then the year that we're looking for then because we're starting in 2000, is January. Make sure you write this really clearly, 2034, to get the 3 marks. Don't lose that 1 mark just by not writing down exactly what the question wants you to do. Okay, so this is A, B, and C. So you can look through the mark scheme and see where we pick up all those marks. Right, on to a slightly different style of question. You can see it's question 19. So again, quite far on in the Ad Maths exam, and a different style of question to what we've done so far. I try and do lots of variety in this kind of video. So variables x and y are connected by this particular relationship. So y equals ax to the power of n, a and n are constants, and we need to put it into straight line form rather than working the other way around. So first thing we need to do is work out logs on both sides. So I'm going to use ln here, ln y. It doesn't specify we have to use ln necessarily, but I can see later in the question it expects us to. So natural log of y is equal to the natural log of ax to the power of n. I'm kind of working backwards to what we've done in previous questions. Now remember, if we're multiplying with logs, we can then add them separately. So what I mean by this is we can write this as the natural log of a plus the natural log of x to the power of n. Again, the benefit of working with logs. And remember, if we've got a power with a log, we can bring it to the back. So when we get the natural log of y is equal to the natural log of a plus n natural log of x. So we're kind of used to working in this direction, but this question is wanting us to put it into straight line form. Notice this is crudely in the idea of y equals mx plus c. Okay, this would be the m part, this would be the c part. So we've now written it in the way that they're looking for. And now we've got it in this form, when natural log of y is plotted against natural log of x. So we haven't seen this kind of situation so far. It goes through these particular points, 0, 0.5, and 3.2, 1.7 is obtained from that. And then we can work out n and a. So rather than doing it in the way that I did the previous question, I'm just going to do this like the mark scheme did. So I'm just going to substitute values in and see what we get. So remember, this value stands for the natural log of x, and this value stands for the natural log of y. In fact, it's good to just label these straight away. So let's start with the first one here. So we have the natural log of y is equal to 0.5. We don't know what a is, and we don't know what n is, but we know natural log of x is equal to 0. So this is going to disappear. 0 times n is just 0. So we get 0.5 is equal to natural log of a, but we need a itself. So we need to raise both sides to e. So that again gives us a on its own is equal to e to the power of 0.5. I'm going to leave an exact value. Again, we could work it out to decimal if we wanted to. So what does that give us? E 0.5. I don't know it off by heart. 1.65 rounded. Doesn't say it wants it to 2 dp, but we'll put that down. Okay, so we've used this bit of information. Let's now use the next part. Now we know what a is. So when natural log of x is 3.2, natural log of y is 1.7. So we have 1.7 is equal to, well, we know what natural log of a is. It's just 0.5. We knew that from previous part of the question. And then we have n lots of natural log of x, which is 3.2. Okay, so that's just an equation to solve here. So that gives us then 1.7 equals 3.2m plus 0.5. So that gives us then 1.2 is equal to 3.2n. So n is equal to 1.2 over 3.2. What's that going to be? 12 over 32. 4, isn't it? Nope, so 3 over 8. I hope you can still see that on my screen is not blocking that. So n is just equal to 3 over 8 for 4 marks. 4 marks is pretty generous there as well. Yeah? I haven't done that much mathematics to get those marks. Okay, and now we have to use that those facts in order to work out x and y. Okay, so find the value of n and a. So we've done that now. So we've got y is equal to a was, I mean, we can use either, I guess, here. So I'm going to write it as e to the power of 0.5 times x to the 11, so 11 goes inside, and n was what, 3 over 8, wasn't it? So we just need to work that out. So I've just written in all the values. Remember, I'm using this equation here, so I'm using y equals ax to the power of n. I've worked out a, I've worked out n, I'm now putting in x, and then we can work out y. So just need to type that into my calculator. So this is why I always like using precise values, so we don't get any rounding errors. And we have to make sure that we're putting this in the right place. There we are. So 11, and then to the power of 3 divided by 8. See if that does that. Okay, yep, 4.052. And again, I'm going to round to 2 decimal places, so 4.05. I always write the actual value my calculator gives me as well. Gives me all of the marks. Okay, so you can have a look through, so you can see exactly where we picked up questions 19A, B, and C. And if you're struggling with AdMaths and you need a bit more practice on trigonometry, because that's a big topic at AdMaths and it prepares you really, really well, of course, for A-level and IB higher level maths, then check out the video right in front of you, where I take about an hour going through the really important topics on trigonometry that you need to know, and probably a bit more detailed than this topic, because it's a slightly smaller topic, but really, really helpful for you.